morning, everyone. Welcome to our virtual classroom. I'm Sir Nixon T. Diraco, your mathematics teacher, and don't forget, honesty is the best policy. So, today we will be discussing about the first part of the geometric sequences. So, what you need to know at the end of the lesson, you will be able to illustrate geometric sequence, differentiate a geometric sequence from an arithmetic sequence, and lastly, appreciate the importance of geometric sequence in real life. What is a geometric sequence? A geometric sequence is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio, which is commonly represented by R. Let's have an illustrative example. So for illustrative example number 1, the number pattern 1, 2, 4, 8, 16 is a geometric sequence. 2 is multiplied by any term to get the next term, if you are going to look at the pattern. Therefore, we can say that 2 is the common ratio. The common ratio may be an integer or a fraction. It can be negative or positive. It can be found by dividing any term by the term that precedes it. The number line below illustrates the sequence. Okay? If you're going to look at the number line here, given that the first term is 1 multiplied by 2, that will give you 2. Next, 2 will be multiplied again by 2 and you will get 4. And 4 will be multiplied by that fixed number, which is 2, to get 8. And 8 will be multiplied again by 2 in order for us to get 16. So that is the fixed number multiplied by our preceding term, and we call that as the common ratio. In other words, using the picture above, we illustrated and proved that the common ratio is equal to 2. Very good. Now let us determine the next two terms in the given sequence: 1, 2, 4, 8, 16, and so on. Since the common ratio is 2 and the first term is 1, multiplying the first term by 2, which is our common ratio, we will be getting 2, and that is our second term. Then that second term will be multiplied by 2 again, which is equal to 4, and that is our third term. Then 4 times 2 will give us 8, which is our fourth term. 8 times 2 will give us 16, and that is our fifth term. 16 times 2 will give us 32, which is our sixth term. Then 32 times 2 is equal to 64, which is the seventh term. So thus, the next two terms of the geometric sequence, 1, 2, 4, 8, 16, are 32 and 64. So what do you think are the 8 and 9 terms of the given sequence? Can you answer that? Very good. The 8th term is by multiplying 64 by 2, which is 128, and multiply again by 2 to get the 9th term, which is equal to 256. Very good. Let's have illustrative example number 2. In the sequence 3, 8, 13, 18, 23, and so on, there is no common ratio among the terms. However, there is a common difference of 5. Okay, to prove, let us have the following solution. So if you're going to look at the uh, the sequence here, if you will subtract the first term from the second term, so that is 8 minus 3, and it will give us 5. The next 13 minus 8 will give us also 5. 18 minus 13 is also 5. 23 minus 18 is also 5, meaning there's a common difference of 5. Thus, this is not an example of a geometric sequence, but it is an arithmetic sequence. Let's have illustrative example number 3. In the sequence negative 20, 10, negative 5, 5 halves, the common ratio is negative 1 half. So let us prove. So to prove that, we're going to divide the second term by the preceding term, which is negative 20. Negative 5 will be divided by 10, then 5 halves will be divided by negative 5. So what is 10 divided by negative 20? Very good. The answer is negative 1 half. Since positive divided by negative, or whenever we divide unlike signed integers, the answer is negative. So the lowest term here is 1 half. Why? 10 and 20 can be divided by 10. So 10 divided by 10 is 1. 20 divided by 10 is 2. So the quotient here, or the ratio, is negative 1 half. Next, what is negative 5 divided by 10? So this is the same as the first ratio. This is dividing unlike signed integers, so the answer is negative. 5 and 10 can be divided by 5, right? Okay, so 5 divided by 5 is 1, 10 divided by 5 is 2. So the ratio here is negative 1 half. Lastly, what is 5 halves divided by negative 5? So to simplify this, we can actually reciprocate this divisor negative 5. So this becomes negative 1/5 and proceed to multiplication. So whenever we multiply unlike signed integers or fractions, so to speak, in this given example, the sign is negative, right? So you can cancel out 5 here. So what you have is negative 1 half. Or you can multiply the numerators and the denominators. So 5 times 1 is 5. 2 times 5 is 10. So what is the lowest term of negative 5 tenths? Very good. Negative 1 half. So thus, in that given solution, we prove that the common ratio is negative 1 half. And the sequence is an example of a geometric sequence. Let's have illustrative example number 4. Determine if there is a common ratio or common difference in 6, 12, 14, 28, and so on. So to prove, let's have again the following solution. Now for finding the difference if there is a common, we will be subtracting the first, right? Subtract the first term from the second term, and so on. So what is 12 minus 6? The answer is 6. Next, but 14 minus 12 will give us only 2, while 28 minus 14 will give us 14. So if we're going to look at the differences there, we don't have common difference. Okay, let us divide the the second term by the first, third term by the second, fourth term by our third term. So that's this is 12 divided by 6 will give us 2. 14 divided by 12 will give us 7 sixths. Okay, or its lowest term. Since 14 and 12 can be divided by 2. So 14 divided by 2 is 7, 12 divided by 2 is 6. So that's why we have 7 sixths. Then lastly, we have 28 divided by 14 is 2. If you're going to look at the result of the ratios, we don't have common. Okay? So thus, we prove that it's neither an arithmetic sequence nor a geometric sequence. Okay, so that's all for today. So don't forget, honesty is the best policy. And happy learning. Thank you very much.